All right, continuing in chapter 7, section 2. Here we're looking at example 7-6 on page 385, pertaining to temperature on Thanksgiving Day. It says a random sample of high temperatures for 12 recent Thanksgiving days had an average of 42 degrees Fahrenheit. Assume the variable is normally distributed and the standard deviation of the sample temperatures was 8 degrees Fahrenheit. Find the 95% confidence interval of the population mean for the two temperatures. Okay, so one thing to kind of keep in mind here is even though the variable is normally distributed, we're still going to be using the t distribution. Why? Well, one very strong giveaway is we are looking in chapter 7, section 7, section 2, talking about confidence intervals for the mean when sigma is unknown. And therefore, we know we have to use the t distribution. Well, if we didn't know that, so if we were looking at a test, no, I don't have to clear my throat. I already said it was for the test. It's not a hint. It's a device. If we were looking at this on the test, we would not know it was from chapter 7, section 2. But what is the what is the key here? It says the sample standard deviation. So the standard deviation for the sample is 8 degrees Fahrenheit. Say 8 degrees. The average temperature for these 12 days was 42 degrees Fahrenheit. The sample size, therefore, is 12. We are told to find the 95% confidence interval, so alpha is 0.05. Or, well, in this case, since we're using the t distribution, we can just say it's the 95% confidence interval. Okay, and so here we can just directly look up the t subscript alpha over 2. The other thing that we might want to remind ourselves of, instead of saying what alpha is, because that's not going to be so necessary, instead of saying that, let's say what our degrees of freedom are. So we know what n is. To get the degrees of freedom, that's just going to be n minus 1, but it might be a good idea to kind of just go ahead and plainly write that down so we don't have any reason to mess that one up. Okay, so I'm quickly just going to look this up. And we have 11 degrees of freedom. We want 95% confidence interval, so we are looking at 2.201 as our critical t subscript alpha value. Okay. All right, what's next? We have to go ahead and construct our margin of error. So the error bound is going to be our t subscript alpha over 2, critical t value, times s divided by the square root of n. Okay, so here we got 2.201 times 8 in place of s divided by the square root of 12. And I'll pause briefly to ask my calculator what that says. Okay, so 2.201 times 8 divided by, let's see, second square root 12. What does that say there? It's 5.08. Okay, so, well, we'll probably just round that to 5.08. Okay, so our margin of error is 5.1, let's call it. Mu, therefore, is going to be chi bar plus or minus E. So what that means for us is we'll take the average chi bar plus 5.1, so that's 47.1. And then 42 minus 5.1, so that'll be something 0.9, 46.9. No, I'm saying that wrong. 36.9. Let's try that. 36 plus 0.1 is 37, plus 5 more gives us exactly 42. Okay, so I'm happy with that. All right, so 95% confidence interval for the high temperature on Thanksgiving Day is going to be between 36.9 degrees and 47.1 degrees Fahrenheit, based on this sample size of 12 months, their sample average being 42, and their sample standard deviation being 8. Again, reiterate, the sample size is 12, gives us 11 degrees, 11 degrees of freedom. Finds for us this t subscript alpha over 2. We construct our margin of error like so, and then go ahead and add that onto the average, get the upper bound of our confidence interval, subtract it away from the average, and get our lower bound for a confidence interval. Sometimes some books or some stats teachers may ask you to write it like this as an interval. So you could say 36.9, comma, 47.1 parenthesis, like that. That would mean the same thing. Let's see. Most of the time, I prefer this. Okay. This one right here, I only allow myself and you to use it as a shorthand notation, as an in-between way of explaining yourself, writing down what it is that you are saying. It's a little brief description. But here would be the final answer. Okay. If you like, you can write it like this, so you leave out the inequality symbols in the mu. All right. So let's move on to the next example in the next